We are going to look at PLC Selection, Components, and Communications. This is Chapter 2. Y'all probably will be happy to know there is no math in this chapter. So Chapter 3's got all the conversions and all the hard stuff. So, all right. We're going to, in this chapter, particularly in this first part of this chapter, we're actually going to come up with questions rather than answers. What questions do I need to ask? If I need to go buy a PLC, what do I need? How do I determine what I need? And what questions do I need to ask to figure out what I'm going to get? Okay. We've already kind of looked at modular and fixed, but we're going to look at that some more. We're also going to look at some processes. We're going to look at how to program the PLC, maybe not actually sitting down and programming it, but we're going to look at different ways that PLCs are programmed, and we're going to look at types of PLCs. So a PLC, we've kind of discussed some of this already, but if it's important, I have to say it more than once. So a PLC is nothing more than an industrial computer. It is a process control computer. It controls some process. Like I said, it's an industrial PLC, so it can withstand dust. They are designed to handle extreme temperatures from super hot to super cold. They handle humidity just fine, so they work fine in Alabama, right? Electromagnetic noise, so motors running and things like that do not disturb these computers. They are designed with such shielding that doesn't bother them, okay? PLCs are easy to operate, they're easy to program, they're easy to maintain, and they're easy to repair, as long as you know what you're doing. Do what? I'm going to show you the easy part of the program before you get out of here. It is easy compared to what it used to be, particularly. If you ever had to program that guy, would you hold that PLC up, please, that GE Series 1? If you ever had to program that, what we do now is extremely simple. That programmer on the top of that only programs in hexadecimal. And you see about 4 digits at a time. So if you ever get interrupted, you got to start over, and you had to convert everything from that to a program. So you had to know you really know what you were doing to program those. So now it's fairly simple. You actually get a picture on the screen. It's almost, I probably shouldn't say this on the recording, but I'm going to do it anyway. It's almost like going to McDonald's in the 80s when people actually had to know the prices of things. And now they get to push a picture of a hamburger. Okay? It's a whole lot different. You get to actually see on the screen what you're trying to make it do. So when we get to the point where you can understand the ladder logic, when we get to ladder logic, then this is really easy. Okay? Things we need to think about when we are selecting and installing a PLC. Manufacturer support. And are my manufacturers going to support me after I get this? If I get this and start installing it and have a problem, is there anybody I can contact? Okay. That's always a question that we want to have. What if down the road I decide that I need to expand this PLC? Is there somebody that'll talk to me? What if I need to just change the program in it? If I get into a problem, is there somebody I can talk to? So all of that is what I would say in manufacturer support. I guess I should just read down this list because I think I do this individually. Serviceability, flexibility, expandability, programming software, is it easy or hard? Training, documentation, and then the cost of them. Notice my cost is at the bottom. So the model, considerations for support, will the PLC manufacturer maintain and replace components? If it breaks, how am I going to get it fixed? You know, is it obsolete tomorrow if I buy it today? The initial cost, you know, that may be some consideration, but I would more consider what support I could get in replacing things, adding things, and upgrading. Okay? Serviceability is, does the manufacturer service the PLC themselves? Do they have local reps that will service them? If I have to send this back to a service center or get somebody out here for it to be serviced, how far is it? Am I going to have to pay travel? That's something most people don't think about. And that's another issue. So if they've got to get a flight out of here, what if they're snowed in? You know, so downtime is another issue by how far they are away. What type of warranty does it have? You know, do they have a replacement warranty where they'll send me a new one and I can ship the old one back? Or, you know, how much, if any, cost is attached to the service calls? So that's back to that travel, right? This is off of PLCs, but Mercedes purchased some KUKA robots. And there was not a service center anywhere near the southeast region. So Mercedes talked to KUKA and was not going to purchase the KUKA robots, and that KUKA decided there were so many robots that Mercedes was going to buy from them that they would put a service person at their facility. So they hired somebody, and now they have a service person at the Mercedes Center. The only reason we purchased a KUKA is because we knew that we could contact the guy down at KUKA. As a matter of fact, he had to come up here and fix the thing when I got it, because I had an argument with the company. So, you know, serviceability, and we are talking about PLCs, but a lot of this stuff we're discussing is on anything, any big purchase anyway. Sure.
About the serviceability, the technical information, why they don't teach anybody else, like don't train them to service those machines or robots or something.
In some cases they do. But KUKA has, if you're talking about the KUKA, it has such a different program that they needed somebody local. It just programs different than the others. So they needed somebody local. Plus, there was nobody in the area. It wasn't that they couldn't have somebody else training on them. It's that there was nobody else that used them in the area, so there was nobody to train. So they needed to have a presence, and in order to get a presence in Alabama, that's what they chose to do. So, but yeah, they could have sent somebody and then trained somebody else and had them there. But you know, I don't know. I just know they put a service person down here. They actually work here, I think it's 2 years, and then rotate back home, and they send a new person, or something like that. So, and I think the actual center is in Michigan, but I'm not positive. Don't quote me on that. All right. Flexibility. How flexible is it? Can I upgrade the PLC? You know, is it going to work for my application? You got to make sure that whatever you're needing, it works for. If I'm going to purchase a PLC and I decide I think there are 8 outputs on this guy, I'm guessing. But let's say there are 8 outputs on this thing, and I know already that I'm going to have 9 things that I need to run. Why would I buy this one? I'm already behind, right? So you got to think about, is it going to benefit what I mean, is it going to be enough for what I need? I'm probably going to make sure that I have 2 or 3 outputs left over and 2 or 3 inputs left over just in case I decide to do something else. Okay. And can the input and output voltage levels be modified? If I need to change, if I'm not running a motor on 24 volts, can it be modified so that now I can get 120 out of it or 240 or whatever I need? Okay. So that could be a consideration depending on what industry you're in. Can we add memory to it? Can I upgrade it? Can I add more input and output modules? Well, if I buy that Slick 1000, that MicroLogic 1000 over there, no, I can't. If I buy the 1100, I can. I just buy a little module. It costs a little more than the module does, but I buy a little module and it's in its own little case and it plugs right into it. And I expand it. If I buy the Slick 504, I buy a card, plug it in, and I have extra modules. And when I'm talking about upgrading, how much is the upgrade going to cost me? And I use a lot of practical stuff trying to let you understand, but how many people have bought a inkjet printer lately? Anybody? Okay. Even several years ago, you could go buy an inkjet printer for $60, $60, $70, right? How much were the ink cartridges? No, they were twice that. They were about $100 to get the 2 ink cartridges. Most people I knew were throwing the printer away and going buying another one. I mean, if you're going to have to pay more for the printer than you are for the ink, why would you buy just, So, what cost is involved when I've got to upgrade? So, if you're going to buy a printer, why would you want to buy a little cheap printer? Now, if you don't have the money, I understand that. But, why would you want to buy a little cheap printer that when the ink goes out, it's going to cost me twice what the printer costs to get ink for it? I'm probably not going to do that. Only reason I know that is I bought one for Christmas for my sister and then realized that the ink cartridge was twice what the printer was. Okay, so that's the expandability. The programming software, why do I want to add extra problems to myself? Okay, I want easy software. So you got to think about the initial cost of the software. When I buy that PLC, I don't get the software with it, guys. So I've got to buy the PLC and I've got to buy the software. If you buy a Siemens PLC, they give you one license with the PLC. If you want more, you got to buy them. But they give you one. Allen Bradley doesn't do that. Allen Bradley PLCs use Rockwell software. Okay? So they don't give you anything when it comes to a license on your software. So, would I want to buy Siemens because they give me the software? Maybe. I don't know. It depends. I'd look at the future upgrade costs of the PLC, of the software. Right now, the software I told y'all I have over there is good for 1 year. I have to re-up that software every year. Okay? You can buy software or you can lease software. Leasing it's just a lot cheaper. So while I'm, You know, I told you I have that software and it's really expensive, but I still only get it for 1 year. I have to purchase it every year. Where if you were buying it for your company, you would probably just buy it and then find out how much it would be to upgrade it. You might want to find out if you can get a site license. Everybody knows what that is, right? Site license means I can use the software all over this facility on this site. We've got a drafting software, Autodesk, if anybody knows much about drafting. But we bought the software and for a little more than the lease price because they had a deal for education. But there was a catch. I can only use it on this campus because this is the site. I cannot put any of it on the Birmingham campus. So I had an instructor over there, so I moved him over here. And all the drafting classes had to be taught over here. But that's their rule on the site license. It had to be a physical site. I could use no licenses off of this campus. They really didn't want me to do it in 2 different buildings. I had to fight with that one, but they said as long as I was on this campus, they'd let it go. So there are, a lot of times there are stipulations, and you can say, well, how would they know? They may never know, but what if they decided to come out here and monitor, and then you've bought it and they pull it? Does it use graphics as opposed to hex or binary or something else, a programming language? Okay, so those are things that you might want to find out. If this is the first time you're putting a PLC in, are they going to send you for training? Are you going to have on-site training or off-site training? Are they coming to you or do you have to go to them? You know, if you have to go to them, then that's an added expense unless they're going to pay your travel, your hotel, all that stuff. You need to find out how much the training sessions are. Not to mention how much it would cost for the hotel, how long the session is, how many days. So now you got to think about, you know, how far away is it? If it's Atlanta, I can drive. If it's California, I'm probably not driving. I have gone to Indiana and drove for a training class, but it was a whole week class, and I had Sunday to drive down there and Saturday to drive back. So, you know, or it's actually out on Friday afternoon. So, documentation. What kind of documentation comes with it? And this is a little old, okay? But, you know, is the documentation on flash drive? Is it on the internet? Is it on a CD-ROM? And believe it or not, I still have one one Rockwell software that I have 16 licenses for. I own it, and the licenses are on floppy drive. Well, most of my computers no longer have floppies, so I have a hard time getting those off of that floppy drive and onto the computer. I think I've just about figured out how to put it on a flash drive. But right now I have a USB floppy drive that I have to walk around to those computers with, plug in the floppy drive, and get my license to move over. So, you know, be careful about getting it on some kind of media that's going to expire. However, we didn't really think floppy drives were going to go away that fast, you know. So you do what you have to do. And then what's the initial cost? How much does the PLC cost? How much does it cost for a replacement? How much are repairs? You know, how much is it just for them to even look at it? I know y'all have run into that on some things that you have probably. we'll look at it, but it costs you $25 for us to even assess if we can fix it. You know, so some of that happens. And then how much is it going to cost to program? Are you going to train somebody in-house, or are you going to get somebody to come in and program it? Okay, so any questions on those? That's basically the 8 things that you need to think about, and some of the questions that you need to ask or think about under every one of those. So that's the questions for this section.
I have a question about manufacturer policy about the fire license. If you was to purchase the software from them, why would they have any kind of problems with you having that both companies have that?
Because even though you purchase the software, it's actually considered a permanent lease. So they still maintain ownership of the copyright. And so if you move it from one campus to another, then they can actually then the contract is voided.
Another way of making more money.
It is. So what they wanted me to do was buy software for here and software for there. But I had an extra classroom over here that wasn't being used, so I took the instructor from there, and I told him, I said, well, let's move you over here just for a couple of semesters and see how it works out. If you want to use the software, then we'll figure out, and you want to go back, we'll figure out how to get it. And when he got over here, he didn't want to go back. So our facilities were much better than his. Yes, it is. My husband, that's what he used to do, was internet security, and they are definitely that way.
Because the last one we actually bought one that had 3 licenses with it. That way we could use it on all 3 computers at the house versus having to buy 3 separate copies of it.
Right. But if you take that from your house and put it on a computer at your office, they're going to have a fit. So, and yeah, I have several copies of it myself. That's the only one my husband will use, and he was security, so it's okay. All right, here are some components, and I said I wasn't going to have to write, but I guess I am. Here are some components, and this is starting to get us into some of the diagrams and symbols. So in PLCs, for those of you that have had motor controls, some of the symbols are a little different in PLCs than it is in motor controls. Okay, like this bell. This is a bell symbol for motor controls. This is a symbol for a bell in PLCs. It's a circle. Every output is a circle. It don't care what the output is. It's called an output. Okay? So every output is an output. That's all you get. It's a circle. Now, granted, it does have the 2 lines coming off of it so that you can hook it into something, but that's all you get. So if that's a bell, you put a B in the middle of it, or you write bell up above it, so you know it's a bell. If you notice, I'm not sure why they're calling these. Let me go back to this picture in the book. By the way, this picture in the book is on page 37. They are calling this typical PLC trainer schematic diagram or components, I/O components, input-output components. I have the old name, I'm sorry. But just glancing at this, they're showing it to you as motor control components, okay? So PLC motor 5 and 6. I don't know why they called them 5 and 6. Some of these things I can't really answer. Of course, they have on the far right over here, they have voltage, and then they have a AC common and a ground. Y'all see that? You see it? Okay. All right, and if you notice, what I really wanted to point out to you, see where it says input ports and output ports? See those? What those are, now I'm just using this PLC because it's easier. I'm going to pass this around again, but if you look up here, you have I/0, I believe, I/1. Where it says I/something, that's an input. At the bottom, you're going to see O's, that's an output. And all that is, with those circles, all that is are these screws. So if you were actually going to wire this, you would back out this screw, run a wire underneath it, tighten the screw back down. And that's where you'd put your push button. Okay? All right. Now, every input that we use, okay, this is not the finished drawing. No, where's your lab book? Who's got their lab book out? You got yours out. If you got your lab book out, just flip to page 80. I don't know if... Oh, they've also got it, I'm sorry, on page 39, which is the next in your book. But it's 80 in your lab book. So notice that the 120 or the voltage is up above all of your inputs. So in our diagrams, all of our inputs, one side of them is going to be tied to 120. And then it's going to be tied to an input screw, okay? All your outputs are going to be tied to common and then to an output screw. Everybody okay? And the one on page 38 has a lot of them, so it really lets you see how they've hooked them up. This wasn't in the original version that I did this from.
How would you have more inputs than you do outputs?
You're probably always going to have more inputs than you have outputs. I mean, because, well, no, I'm not going to say that. It depends on how many things you want to use to run each input. If I'm only running one motor, I'm always going to have more because I'm going to have a stop and a start. Okay. Right? But now if I use that stop and start to start more than one output, but I've got to have a stop, I got to have a start. If I have a temperature switch, if I have anything else that I might need on there, every one of those get their own input place. The hot side comes out of one place, and so all of them connect to the hot side, but each one of those will connect to a different input screw. So they all have their own input location. Okay? So that's why you'd have more than one. All right. You actually have to draw those when you start that part of your lab. You'll actually have to draw in how you would wire it. So you draw in the wiring diagram. Oh, I do have it. Okay. We talked about these the other day because we passed them around, but I'm going to go through this again. This is a modular PLC. We need to walk across the hall when we get through here and look at the Allen Bradley. We'll just walk to the back and look at it. But this would be the power supply module or power supply. The very first module which is always numbered 0, is the processor module. And then your next two can be your input and your output, or you can, you know, space them out. You could have 2 inputs and then 2 outputs, whatever you have. But ours is input and then output. And I have them all that way so that when you program them, I know that you're programming them. I mean, you're using the right addresses because they're all the same. I mean, your addresses are not going to be identical, but they're going to be really close, and I can tell if you're right or wrong in using that. Okay? This is back to the input wiring. So when you open up these flaps, which is basically the same thing, let's pass that around. If you don't mind, y'all look at it and then pass it back. But if you open those up, you actually have those screws, and you can see wires underneath them, and that's all it's showing here. It's just instead of it being on top and bottom of the PLC, these are vertical, okay, instead of horizontal. And we'll go look at these in the lab. It's just on a big old huge trainer. I'm not going to try to move it around. We have inputs that we will use in real life, so there'll be real world switches, push buttons, switches, push buttons. We don't need relays anymore for this. We don't need temperature switches we can use. You might have a float switch, so any kind of switch you can think of and any kind of push button you can think of. Those would all be your inputs, okay? Then we're going to take those, and the PLC does all of this decision making. So on that temperature switch, if the temperature raises to what do I do? Well, this monitors the temperature of that temperature switch and determines what it needs to do. Okay? It monitors that float switch to see if I need to turn on or off the water depending on what I've set that float switch for. Okay? But the PLC does all of the decision making. Remember the old, for those of you that's had motor controls, remember having to wire up the relays because the magnetic contacts had to be energized to keep it on, to keep it energized? We no longer have to do that. The PLC, if I put a relay out there, the PLC knows that if this is on, this needs to stay closed. So it does that as logic now instead of an actual component. So you won't hear it click, okay? All right, then it takes, after it does the decision making, it decides what goes through, and then it will turn on or turn off the motors. They're not actually wired together. So when we do motor controls, we take a wire from the hot. We go into the first, the stop. We come out of the stop and into the start. That same side of the start has to go down to the control relay, right? Or the relay, the seal-in contact, right? Contact. The other side of the contact comes back up to the other side of that start button. The start button then goes down, and we'll say it goes to the motor. Okay? Then the other side of the motor goes to the ground side. Okay? We don't do that anymore. All that middle part, gone. I take a switch, I hook it up to the hot and to one of the input terminals. I take the next switch, hook it up to the hot and another input terminal, and I take the motor, hook it to the ground and the output terminal, and that's the wiring. The PLC decides what's connected with my program. So we don't actually connect those anymore. They connect through the PLC. Okay? Now, what did I do with that? There it is. All right, so this is another way of showing it. So here's your 24 volts if we're using a 24-volt system. All the hot side is connected to whatever switches you want to use, and it's connected to the PLC. All of my outputs, I got a solenoid, a light, and a motor, and they're all connected to my ground. And that's it. So what it's telling me here is this is not touched. So I have power coming through here. And however they've done this, this one is programmed so that this motor turns on. But there's no link, there's no physical link between that switch and that motor. It's done through programming. I really wish they would have put the little programming right there on top of the PLC so you could see the program. I might have to figure out what it is. Okay, so those are linked using the PLC. I guess this would be 1, 2, 3. I'm sorry. This would be 0, 1, 2. 0 and 1 have to be connected to get the solenoid to come on. Well, no, this is not the right program. This is a different program, but this would be a PLC program. Now, normally when you do these, you're going to label these. Okay, if you just put this program out there, I can sit and figure it out, but I don't know what any of those switches are. Do you? I know they're all normally open, but other than that, that's all I can tell you about them. So if I have a problem at, let's say, the output number 1 over there is not turning on, where do I go look for the problem? Yeah, but that's the program. The program's not usually the problem once it's working the first time. The program's usually with the component. So where do I find this? Is it a push button or a switch? Is that a push button or a switch? My guess is this is a relay. Or no, it can't be. It's an input. So I don't know. So if that's not coming on when I think it's supposed to, then I've got a problem here, here, or here, right? Think about troubleshooting, right? So if I have a problem, let's just say that my problem is here. I got 3 outputs. Which of the 3 is it? Now, granted, I can sit and throw the other ones and make them come on and finally figure out which one this one is. But I have to know what if the switches are all over the plant? You know, they're not always right next to each other. Anybody seen the movie Crimson Tide? With the sub movie where they're going to send off a nuclear missile? Where are the 2 keys? Are they right next to each other when you want to fire a missile? One of them's on the, I guess they still call it the bridge. One of them's on the bridge and one of them's in tactical, right? They do that on purpose so that one person can't turn both keys. But it would be like this. Both keys have to be turned to allow that to work. But they're not on the same side of the ship. So, using that example, what if these are all over the ship? And how do you know which button does what? There may be 50 other buttons, and by the time you get through, you may be blasting off a nuclear missile. Oops, yeah. Yeah, yes, sir.
Now, when you read, from wrong zero down, so you start at the top, left to right.
Yes, correct.
So wrong one or wrong two can't be activated unless wrong zero and one doesn't activate. So
No, sir, that's not true.
not so wrong three can still be activated without.
Yes, it can be. You can this is not, I can activate those independently. I could also set them up so that they were activated like you're talking about, where one wouldn't work without this one and this one and this one. No. Well, yes, but it can skip it. I mean, if it's not activated, it'll go down to the next rung. So it's not that you have to run one rung. So it doesn't actually go one right after the other like that. It looks to see what will work and what won't, runs what will work. So you don't have to. So rung one doesn't have to work before you can operate rung two. They can run independently. If rung two's not working, in this particular diagram, it has nothing to do with 1 or 3, if you look at it, because it has its own push buttons, input 1 or input screw 2, and input screw 3, and then output screw 1. Yes, sir. If none of them are working, yeah, it could be the power supply.
I mean, I think what he's saying is when two work, so like we get it like they all just feeding off the main line there.
Yeah. Yeah, and you could have a power supply problem, but that's slim. That's going to be a rare occurrence. That's right. But if rung 1 is working, it's not a power supply. So if anything on this thing was working, then I know it's not a power supply. So I'm assuming that something on this one's working. Okay, let's just say it is. Rung 1's working. But the problem is nobody addressed it. Nobody, you didn't write something down to let somebody know what it is. And guys, I'm going to tell you, I'm a maintenance person, but the maintenance guys that I really, really hate are the ones that are protecting their job and they don't want to tell anybody anything. Please don't be one of those. Please don't be. If you don't remember anything else I tell you in this class, don't be one of those. Okay? This is what one of those maintenance guys would do, because he knows where all those switches are. And he's going to label it at just as little as possible. So that's what the program makes you put in for it to run. And then he's going to have no identifying anything so that you can't come in and replace him. And that's basically what I'm getting at. But now, if I'd have come in here and I would have said up here, I guess I should have wrote this on here, but it doesn't matter. Above I1, I had mushroom, PB, shop 4 wall. Now I know where to find it. So if this guy's not working, I go to the mushroom push button on the shop 4, find it, and I can hit it and see if that push button's working, or I can actually ohm it out to see if that push button's working, or put the voltmeter on it and see if I got voltage now, and push it in and see if I don't have voltage. So I can now do something with this push button. Okay? I'm just going to say this one, but so I'm going to say that this push button is a green push button in the supervisor's office. I know. I'm just looking for something to identify it. So now, if that one's not working, I go to the supervisor's office and I do the same thing to that push button, see if there's a problem. If there's not a problem with either one of those two push buttons, then I got a problem with my output. But that's the only three things that really, if something else is working, that's the only three things that I would have a problem with. And I need to identify those to know where they are. So even as simple as our programs are going to be, you have to label them. I'm trying to get you to the point where you remember to label them. So I don't care if you have one switch and one light. I want it labeled. If it's a red light, I want it to say red. Do something so I know what it is. Okay? This is basically the way, this is basically the way that the screws look, okay? When I'm addressing these, and you notice back on my addresses, I set that thing down all the time. On my addresses, see the I:10? Okay. What that means is this is an input, okay? It is an input in slot 1. This right here is your power supply. It's not considered a slot. Your first slot, which is slot 0, is always your processor. So you should never use 0 unless you're doing a micrologic, unless you're doing a fixed PLC. And I'll explain that in a minute. We're looking at modular. Did that light just flash? Okay. Making sure I'm not going blind. Okay. So that was an input. It's in slot 1. Everything in PLC starts with 0. Okay, so 0, 1. Okay, it's in slot 1. The very first screw that I have that I can attach to is 0. So input, slot 1, screw 0. Everybody okay? So if this were my PLC, it would be wired right there. And it would be wired down to DC voltage right here, which you probably can't see, but that's the screw that says DC voltage. Okay? We don't use the terminals right now, so. Okay, this is actually the addressing that was used in the older PLCs, so I'm going to skip this. I'm not even sure this is in your book. I think I took this from an old book. Yeah, it's not in your book, so I'm going to skip over that. But I put it in here so that y'all could actually see what the components look like. So this is a 16-bit module, okay? And so what it is it has 16 screws, but it's 0 to what? 15. There's 16 screws that I can attach to for an input, but it's 0 to 15, not 1 to 16. Remember me telling you might want to get you some of those little tag things, those flag things? Well, the reason I do is because the trainer labels them 1 to 9 or 1 to 8 or something like that instead of starting at 0. So if you don't pay attention to the 0, you're going to start you're going to try to do something else, okay? Same thing with the output modules, except with the output modules, with the output modules, now you'll have an output, okay? So it'll be an O. That's not a 0, it's a O for output. It would be in slot 2 because I have 0, 1, and here's my output, because this is all input. All my outputs are in 2. So 0, 2, and then that would be the first screw, so it would not be this one if this were the output module. It would be this one. Y'all with me? Okay, good deal. Okay, so here's where they connected the solenoid, and it is connected to the ground, and it is connected to the output terminal O:20. And the push button is connected to the 24 volts. Then it's connected to the push button and to input 0. So this is I10. No module number. Module 0, which is the processor. Module 1, module 2. Got to have the 1 or the 2. Because what you're doing is telling the PLC where it's located. Okay? Because you might have 2 or 3 input modules. Alright, so basically this is what it looks like. Okay? I have all these switches hooked up, and I have it connected to a part of the PLC, but all of this is hot, all of this is ground, and all of these are just connections to the PLC. But there is nothing connected up that center. The PLC makes all the connections from in here. So we don't connect them anymore. We don't wire them. One nice thing is if something happens and you get some kind of surge on one of the motors or something, it doesn't go back to another one because they're kind of isolated, which is really nice. Okay? All right, I think I got enough pictures of those. This is actually a screenshot. I don't know if this is in your book either. I don't think it is. I think this is my screenshot. This is a screenshot of a PLC program. Okay? So notice our rung numbers. And I should have gotten I should have put one in here with a parallel branch or something, but in motor controls, you would label this one, and then if you had a branch, was it considered another rung? It's not in PLCs. Okay. But notice all the switches look the same. They're all contacts. And that's all we look at them as. That's why we've got to name them, push button or switch or whatever. All the outputs are the same. It doesn't matter if it's a light or a motor or a bell or a buzzer or a solenoid. It's all a circle. There are a few other outputs. There's one that looks a little different. It's called a latch. It's called a latch, and it works like a seal-in circuit. So you have to turn it on and turn it off, but it just looks like a double circle. All right. I think this was one of your questions that you had on Chapter 2, but we have two different types of memory in the PLC. We have user memory and we have system memory. I'm going to do these backwards. The system memory is all of the programs that need to be there so it knows what to do. It is the program. I don't mean the software. It is the program internal to the PLC. Basically, it tells it what a push button or what an input is. It tells it what an output is. It tells it, you know, if you use a timer, what is a timer? If you use a counter, what is a counter? So it uses those. The user memory is the majority of the memory. It is 75% of all PLC memory. It is your program. When you develop a program, you have to upload it to the PLC. While it's holding your program, that's 75% of the memory that it has is set aside for that program. The programs that we do in here might be, I think the largest one we do is just before the final, and I want to say it's like 10 or 12 rungs. I have seen programs in industry that are close to 100 rungs. So they can get very complicated very quick. They can also take up a lot of memory. So that's why 75% of the memory is allocated for or for your programs. Everybody okay? That's really just the execution information is system memory, and it's only about 25%. It is. Well, it's not just the names; it's what it is. So, what is a timer? How does it operate the timer? If I tell it it's a timer, then what does the PLC need to do to it? It's telling the PLC that if I tell it to link this and list, this is what it's supposed to do to create the link. So it's everything that the PLC needs to know to be able to execute your program. Yes. It's in your computer. There are things that the computer has to know before it ever loads the software. Like if you buy a computer, it still has. You have to do something. Right, but when you put memory in there, it has to know how to even find that memory. Where is it? Where do I need to go look for it? And that's the kind of stuff that's in that execution information. Right, it's stuff it has to know, you know. The memory sections are basically the input image status, the output status, the timer status, the counter status, and all of the functions. These are part of what goes in that. So this is my list of things that actually go in that system memory. So this is some of the things that go in there. So where do I find the inputs? Where do I find the outputs? Or what is it? You know, what's a timer? What's a counter? And then adding, subtracting. How do I compare numbers? How do I divide? You know, what do I do if there's a status? This is basically kind of what it looks like. And I've got the system memory showing a whole lot larger, but just because it has a whole lot more sections, but they would actually be much smaller. 75% is at the top, and then the input and output statuses. So is it on or off? You know, is it hot or not hot? The timer the timer's status, the counter's status, and then all the logic functions. Okay, I'm not really going to cover this too much because I don't even, is it still in your book? The baud rate? Okay. Baud rate is actually an old serial term. It really means the same thing as BPS, which is bits per second. It indicates how many binary digits can be transferred from one place to another in 1 second. So not 4 bits, You know, not bytes. It is bits per second. Old modems used to transmit in BPS, in bits per second. Most of y'all probably have never used a computer that had a modem hooked up to it. But you would have to dial through the telephone lines, and you'd get better and better modems, but the problem was the telephone could still only handle, I think, 300 bits per second. Yeah, I had a really nice 14.4. And then I got a 56, and I thought I was really doing something. But basically, this was a very slow transmission rate. Your USB drive is a serial drive. It transmits in BPS, but it transmits very fast. So you don't really notice that it's transferring in bits, not in bytes. Serial and parallel, the USB is serial transmission, okay? It is transmitted in bits. So it has to send one bit at a time, and I'm going to flip real quick in just a second. Parallel is faster, but it's more expensive, and it sends 8 bits at a time. And I got a picture to kind of show this. Serial's slower, but it's a whole lot cheaper. So this is a parallel transmission. It has a return line, and then it can transmit 8 bits, okay? That return line, the transmitter says, okay, I'm ready to send, and it waits. Then the receiver says, okay, I'm ready to receive. And then the transmitter goes, okay, and sends the whole packet at one time. Okay? And then the transmitter says, okay, I'm done, and shuts off. Okay, I know, kind of silly, but that's what it does. This is a serial transmitter. The transmitter still says, I'm ready to send. Then the receiver says, I'm ready to receive. And then the transmitter says, boop, 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 till it gets through with all 8 of those digits, and then it says, okay, I'm done, and it shuts off. But it takes a lot more time to send them boop, 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 than it does to send them at once. Silly description, but it usually gets the point across. Okay, we talked about parity the other day, and I'm not going to do parity again, okay, because we use the same exact example, okay. DTE is data terminal equipment. It's the one that initiates the communication, so it requests permission to send, okay? It's the initiator. It is the transmitter. The DCE is the data communication equipment. It's the receiver. It's the responder. It's the slave. It accepts the commands, but it doesn't initiate the commands. Everybody okay? So it's that, okay, I'm ready. Okay. Channel communications, there are 3. Simplex, half duplex, and full duplex. Anybody in here a radio person that's ever used a walkie-talkie or a radio kind of thing? What kind do you get? You know? Simplex. You sure do. You get one direction only usually. You got to key a mic, or you key the talkie. Well, when you got that key down, how many people can talk to you? Nobody. You are talking by yourself. They can try to interrupt you all day long, but until you let go of that button, you can't hear a thing. Okay? That is simplex. I talk, you listen. You talk, I listen. There is no dual communication. Half duplex, well, actually, simplex, that's not true. I'm sorry. Radios are half duplex. Simplex is one direction at a time. It's more like a radio. You can't talk back to a radio. It's got a direction and one direction only. Half duplex is going to be the other way. I can talk, but I can let go of the button and let you talk. So that changes directions from me being the receiver to being the sender, or vice versa. Okay. Now, full duplex is like a telephone. If you're talking, it's like a home phone and not an internet phone. But if you're talking, somebody can interrupt you. You can hear both ends of the conversation. Cell phones, I don't know what the heck they are. They are somewhere between half duplex and full duplex. But you can get people on the phone, and I swear they can't hear you trying to interrupt. You know, some phones just seem to work that way. The Nextels, because they have the radio, a lot of times are half duplex. They're not really full duplex. The Southern Link radios, they're phones, and they're just like the Nextels, but they're really half duplex. They're not set up to be full duplex because they're really intended to be radios that have phones attached to them. So they're really set up more for the half duplex than they are the full. Everybody okay? Okay. For the PLCs, we have a couple of ways we can program them. This is a loader or a programmer. So this is one of those programmers. I took this one off of an old Square D. And that was another one I learned on. But this came off of a Square D, and you punched in your program right here. This connected to the PLC, and when you were done, you could disconnect it, and once you uploaded it, and the PLC would continue to run. You didn't have to have this on there. Okay. So you're more than welcome to look at this guy. This is one of the old Square D modules so this had a four port output, I think. Well, I say that. That doesn't look like an output module. This may be the processor module, huh? Yeah, I think this one may actually be the processor module. Oh, well. The GE, the old GE, that is the programmer. And notice it pops on the front, but it can actually be removed. So now somebody asked me one time, why would you want to do that? Well, if I get a technician if I get an operator out there that keeps wanting to change my program and keeps screwing up my program, I'm going to get tired of going out there and fixing it. So what you think I'm going to do? I'm taking that module off there. Now he has nothing but that, and he can't do a dang thing to my program. Yes. So once you do this and you upload that program, it's really all in here. It goes into the processor unit. So this one actually works backwards from most of the others. This is the processor unit over here. Okay. And this actually plugs into the processor unit right here, the CPU unit. But once it's up in this CPU, I no longer need this anymore. But now what I don't want to do is take this back to the shop and forget what I do with it, because it's kind of a small little thing.
So basically you have a copy on this one, master copy, and one copy on the CPU?
No, this doesn't hold a copy.
Oh, okay.
Once I got it all inputted, it automatically, I upload, I just hit, and it goes up into there. Now the new ones, it will keep a copy on your laptop or wherever you save it.
Mm-hmm. So when you change it, you just insert that one back in here. You change it on this one?
Now, you'd have to put this back in here, I believe, to do it. This one I'm not sure about.
Oh, okay.
Because it's been a long time since I've messed with this guy. The new ones are different. They use laptops and iPads and all kinds of things now to use as an upload. So we don't normally now, guys. It's a good question. So I was asked, does this store? And it normally does not. Okay, and the new ones, the new PLCs now don't use these types of modules for the most part. You use your iPad, you use your Android, you use your Windows pad, you use your laptop. And you connect it up and you store a copy on your laptop and then you upload it into here. So today, we don't really use these, but you need to know where we came from. Okay?
It's like DOS and Windows now.
It is. It's sort of like DOS and Windows. You don't do this hardly anymore. Now you take a laptop out, you hook your laptop up, you run your program. Actually, that's not true. Now you sit in your office, you set the program up on your laptop, you make sure that the program runs by itself, then you go upload it into the PLC. You can simulate it now. So you can simulate it, make sure it works, then go load it up into the PLC, remove your laptop, and be gone. So now you don't have to have all that downtime like we used to have. It used to have to sit there and do it at that PLC. Now you don't have that. And a lot of the reason it changed is from the downtime. Either way works, right? Okay. There are also some old PLCs that had dedicated monitors. We don't use those anymore because our laptops have those monitors. Okay. That monitor would permanently stay with the PLC. I had one, and it actually was about the size of that O-scope right there. And it had a cover that had the keyboard in the cover, and it would snap together and like lock into place on the front of this. And when it dropped down, the screen wasn't much bigger than that. And this was the PLC. And it had a screen, and you opened it up, and it had the keyboard. Everything stayed right there attached. We don't do those anymore. Now, in our lab, we're going to use desktops. Okay? The reason we're going to use desktops is just because they're easier for me to deal with, and I don't have to worry about somebody walking off with my laptops. Okay? So we're going to use desktops, but either desktops or laptops, either one will work. In industry now, the norm is a laptop as opposed to a desktop, because why do you need to put a computer right there by the PLC? That just takes up too much room. So they had rather buy them laptops, let them program them, bring them out, download them, and go back. Okay? So laptop is now the ruler of the programmers. Okay? Any questions?